Hello, Niranjan. Yeah, so,
Hi, Dr. Chandrasekhar. Good morning.
hey, Niranjan, yeah. So maybe I should put so before I start, is it going to be just four of us? I thought it was more. Oh, Aryan, I saw him on the enrollment. Okay, then he should be here. Okay. So I'm Shatish. To begin with, is it okay to record the lecture? There is another faculty who is a collaborator who wants to is probably Niranjan is from Bismarck, North Dakota, correct?
Right, yeah.
Union Tribe Technical College. So he's an alumni from SIU, so probably a resource for you guys. But I don't think Niranjan, you ever took a class with me, right?
No, never.
You have a camera, might help, like others can see you, and I'll show you the other students here. Oh, there you go. Yes.
Robin,
Oh,
all these programs are set up.
yeah. So I'm just taking the permission. Niranjan is going.
You.
Let's say hello to Niranjan. Hold on, I'll change the camera.
That's fine.
Yeah, here you go.
Hi, guys. Good morning.
And Cycle.
How's it going?
Dr.
Cycle.
Kalapatra. Good to see you after a long time.
Yeah. You should make a visit. Yeah?
I can't hear you.
Oh,
You should come to Carbondale. Anyway.
I should. I'm planning on that.
he was considering. Okay, thanks. Second. Yeah, Aryan. Oh no, Aryan. He just tried. Yeah.
She just arrived last week.
And I'm not sure if is it listed 404 or 410? Probably 410. 404. Yeah, it's listed as 404, but everyone came here. If it's available, I think this is better.
Why is this at 404?
I don't know. I went there, but then everyone was here. So
What says on B2L?
I think it is 404, but since everyone came here, especially the new students, I wouldn't be surprised if it is 410. Do you guys know whether it is 410? How do you know it is this room?
So in the course description, there is some document that's showing the.
Then I think 410 is correct. Yeah, let's.
410, right?
Yeah.
Okay, I'll check.
Yeah. Thanks.
Hey, no problem.
Yeah. Okay. Okay, there's one more in the okay, good. Okay, so again, since Aryan joined later, maybe there will be another student joining. I would like to record the lecture primarily. Actually, recording doesn't have to be there. It's mostly it has to be. I would like to have the setup so that Niranjan, who is in Bismarck, North Dakota, I suppose, and he would like to attend this call. So, is anyone have reservations? Let me know. It doesn't have to be now, later. Or somehow, if you don't want to reveal yourself, somehow let me know that this is not a convenient setup, and then we will find it. Basically, this is getting recorded automatically in a sense, and in the past, at least students have said they like it because they can go and refer back and look into this. But I wouldn't be surprised if there might be someone who will be having reservations against it. You get recorded 30 years down the line, you made a mistake, and you don't want it to be, oh, I made such a mistake with someone. You're in a public profile, and it may not be. So be aware of that. That is all. Let me know if you have any reservations.
Set up always or?
I was thinking we will have it at least as far as Niranjan is there. I will take the interest. If Niranjan is not there, then you take it. And I requested Abdullah to set this up. I think he didn't have much choice. I supposed to say no, I almost requested it. So thank you, Abdullah. So to begin with, I am Shatish. Change the camera. You did this first time, right? Yeah.
Can you
Oh, this has to be moved around, right, so that you can. That's. You know? Would that be good?
Did you set up the cameras?
Yeah, I just now moved it actually. Maybe the camera got pressed, I think, because, so this is selection of the camera, maybe. Yeah, so maybe accidentally you pressed 1, 2, so these top 1, 2, 3 is selecting the camera, it's number 1. No? Sensitive to who is touching it, huh?
Did you? The first one.
Yeah, that makes it very. Yes, so we just rotate. Oh, we haven't set that yet.
Oh, that's good.
Yeah, because probably this is used during the song. So. Fetish, and this is. It's 508. Yeah,
It should be.
but then the remote will not work. Oh, this is where it's.
It won't show this.
Okay, okay. So then you can reach this always. Okay, usually these technical problems are minimal, so the first day. So. Okay. So again, this is mathematical methods. If you could tell me your names, that will help. I know Abdullah and Aryan. Let me go from there.
Yeah, it's not done.
Dushmanta.
It's not done.
Right. And
I'm Sandarika.
Sandarika. So you're a PA for me also. You need to meet later again. And Nathan. Okay. Thanks. I've seen you around. I think the first time I'm seeing you. I'm having you in a class.
We're doing one.
Oh. Okay. So, okay. So. I think all 3 of you are probably in the, you're a grad student now, right?
Yes.
Yeah, okay, so you're a grad student, so all 3 of you are in the first semester here, Abdullah and Aryan are ahead, I guess, so big resource. I do think that at this level, the style of teaching of your instructor does matter. So don't be under the assumption that if you have done certain things in another course that might go through in this course also. So that's where do talk to each other, the resources, how you use the resources, what's the expectation from the teacher. I will try to tell that as much as possible, but it might be a lot more efficient to talk to Aryan and Abdullah. Is that clear what I said? So talk to each other. It might be useful. It's not a requirement. I try to tell as much as possible, at least surely the basic stuff, but I often notice that people miss on certain points that I am trying to convey. By that, what I mean is the style of teaching, what's the expectation. The course overall, very broadly speaking, the course content is hard. Probably there is a good amount of work, but I guide you through the steps. I take a big problem and break it into small. So it's almost like working out the steps in a textbook. I think that's how I would describe my course. Would that be right, Aryan? Abdullah? Yeah. So try to look at, and if you work hard, I will reciprocate. If you don't work hard, that's perfectly fine, it's just the grade, so. So there is an assessment part to that. May not be the most pleasant thing in this room, but that's required and that's part of this course, okay. And, okay, so I need to use syllabus. So the room number is probably a hundred. Oh, you did give them, yeah, you printed.
I got up and grabbed.
Oh, okay, that's good, okay. But today I hand out a homework. The homework will be an important part of the course. Okay, we want to name. Okay. Yeah, so very quickly, let me. Go through. This we meet at 9:35. I like this room much better than 404. My liking doesn't mean students like it. Yes, so, yes, please.
Setting the camera is on. Was the number and set or set number?
One and set, number and set, and then you call one and call.
Okay.
Right. What's- Niranjan, is it good? And Niranjan, just remind us if it's not visible or if it's not, if you need zooming in, anything like that.
Sure.
And Niranjan, if you go to my webpage, you should be able to get the syllabus that I'm going to talk about in a few minutes, I suppose.
Okay. Yep.
So we meet in this room. Last year, we met in 404. It's a lab actually. Some people say they like it because it's all distant, everyone gets it all there. But I prefer this room, this setup much better. Okay, and office hours are listed. It is Monday, Wednesday, Friday. It's 3 to 4 p.m. and Tuesday, Wednesday, Thursday. Maybe this requires some. R stands for Thursday, which probably is not very common. I mean, but surely here it's very common. So when I say TWR is Tuesday, Wednesday, and Thursday, 11 to 12. Okay. What will we cover in this? Mostly what I felt was necessary for other graduate courses. So the curriculum says it's mostly differential equations, and I take it a little extra, but again, it's part. I mean, the curriculum never says exactly what it is. So you use a lot of what is called Green's function in the in other courses. So we will do a lot of Green function. What it means is very simplistically speaking. Let's say d squared by dt squared. Let's plus omega squared f of t. What's the solution to that? Anyone? Solution to that differential equation? That's a differential equation.
Some cosine.
Yeah. It is sine and cosine, so what we look for is that which function is something whose derivative, when you take it twice, gives something like omega. And when you add it, it should cancel out to 0, right? So usually you will see this in this form. If I had written it in this form, probably you would have guessed it better, right? That's the simple harmonic oscillator. Second derivative of which function is the function itself with the negative sign coming up. So notice f is equal to sine omega t. Okay, so you can put a there, but then you say that, oh, cosine omega t is also a function. So that usually second order differential equation has two solutions. We'll come to all that in more detail, but broadly, this is all you should be familiar in a normal partial differential equation, or this is not even partial, when the one of the first or second differential equation that you see around. That's good. But what we would like to do is, what if this was not 0? Right? What if this was something else? Let's say that is a g or t. Let me not call it g because g was confused with Green's function maybe. So let's say alpha. So you say this is a source, or earlier it was a homogeneous differential equation, now it's an inhomogeneous differential equation. And these are standard. Take any differential equation and put everything on the left and put something on the right, then it becomes inhomogeneous. And the idea is that is there a standard form of solving this equation in terms of the original equation. You don't want to do more work. You already know the solutions if it was 0. In terms of this, can you do something? And that's broadly what is called Green's function. This technique of solving inhomogeneous differential equation is what is called Green's function. We use it all the time. In electrodynamics, if I ask you what is the electric potential due to a point charge, anyone else answer? If I have a 1 point charge, what's the electric potential because of that? Q over R. Q over R, like you typically say that electric field is equal to 1 over 4 pi epsilon naught. And suppose there's a charge Q over R square, right? And something is missing in that. And potential is 1 over 4 pi epsilon naught Q over R. What is missing in this?
Vector.
Vector, very good. So R. And I'm assuming that this is at the origin. And if it's not at the origin, then you're right. The position of the charge is R minus R prime. And here there is no vector. So that's the simple electric potential we do about. And you will also hear the term that this is nothing but the Green's function for the Maxwell's equation in electrostatics. So that's nothing but the Green's function. So we'll come to that. So that's what you do is that on the right side, that is a point charge. So this is a source. That's your field, or this is your electric potential. So we'll talk about those things. That's broadly what I would like to do. But then in the beginning, we will do a lot of notations, like index notation comes up a lot. Index notation is something that you work with in vectors. How you it's mostly a process, so it should not be too much. But I do notice that students struggle a lot because everyone says you will see it in the other course. Right, that's very common. So one is you say, oh, you must have done this in undergraduate, and in undergraduation you say, oh, you will see it in graduate program, or you say, oh, you see it in the other course. So we'll spend a little time on it. I don't think it has too much depth in it unless you do general relativity. It has a certain extent depth in the sense that it can be used very nicely in general relativity, but I don't think we will have too much time to reach that. I'll construct a few things, maybe construct one curvature tensor in a way. So that's the minimal we might be able to. So we will barely touch on it just for showing that this This has a lot more power than just a notational is. So that's one thing. And the second thing, again, which is usually not done in a typical mathematics course, is the quantum mechanics matrices that we deal with. Are you familiar with what you call a Pauli matrix or Pauli matrices? Right, so there are 2 divided by 2 matrices. There are some nice matrices. So this is sigma x or sigma 1. You can say this is 1 minus 1 further. Let's say this is 0. Huh? Is that what you said? Yeah. Sigma z, let's say sigma x is 1 0 1 1 0, and sigma y is 0 minus, I suppose. So these 3. Oh, print, yeah, please.
Oh,
So
when your class finish?
10:50.
10:50. Okay.
Is this room? available?
Yeah, there's a confusion, so I will take them somewhere else.
Oh, so this is, so that's what I was just mentioning that, so this is occupied, right? But I mean, apparently 410 is listed, Abdullah, you check?
I have to.
Oh, so just not like the past.
But he said I will check it. Yeah, exactly.
Okay, this might be true that it is your.
Maybe you can sit in your class, it may be more fun.
No, I think, we should go to 404.
No, it may not be a,
Uh,
sometimes they make, everybody make a mistake, right?
just, the SIU classes. SIUC. Yeah, go to Google. SIUC classes.
It's 404.
404, right? Yeah, we should move on. Oh, that's right here.
Are you sure?
Yeah.
Oh, I can go there today, so you set it up, just let me in.
Yeah. If they have more than one classroom. Rest are all lab. There's more on the different floors, but this is the one that I think there might be like 1, 2, 4. I've never seen it. I've never seen one at the second floor. Yeah, I've seen that there's the big lecture hall too, but that's, we're not gonna use that for five of us. We use the conference room. That's a quantum, there was an ag. And They moved it all in.
The underground? Or
Yeah, we're underground. Only rolling. Right after this, there's electrodynamics in this room, so. Yeah.
You're taking 3 classes?
Yeah.
In this semester?
One of them is the introductory, one where I go around and meet everyone. I don't remember it was.
Increments.
575, the special topic. Even though I know everyone already, but
Special topics is today. Oh,
it's tomorrow.
it's tomorrow.
Between 4 and 6 p.m.
So you registered 575 or 476?
I'm sorry.
There were 2 special topics, right? One was at 575.
Yeah, there were 2. I mean, we're doing 575.
Next Friday is the first term.
Yeah.
Yeah.
Yeah. September 2nd, I think, so it might be like a baseline midterm.
Oh, they're going to do 3 midterms or 3 exams.
Doing the.
Yeah. 2 midterm.
Is the final cumulative?
Oh,
All are cumulative.
class.
could be shorter than. It's in class.
We can just run this one.
Not just this one.
Right, really?
So who's teaching
Or you did one homework? Or we're done.
Who's teaching part of this?
Right.
New teaching.
New teaching?
Oh,
Oh, there's a new.
what they wanted to. They send an email, right? Or you figured. You remember the same one? No. I don't know. I don't know. No, the same one we had. Yeah, it was 100.7. They were two, right? At first.
One of those information like. Okay. Have you seen Birds Class computing?
I haven't taken.
Yeah, that
It's other brand.
oh, it is.
Different project.
I took it last year.
It's in Spain and home.
Yeah. It was just, it was me and three others. And it was pretty interesting. It was obviously a new class.
It was the first time.
Yeah.
This teaching can this also.
It was good though. Maybe we'll move the midterms. This is my first year.
It might be right going on. Nothing for you.
So what's decided? We take this home or the other? It's nothing is decided actually for now since we have the setup.
Okay, this is better.
We like this room more. Well, that's not a, this is better. That's a bad argument when you're sharing something like this. Better.
They might also say that.
Yeah, that's surely, you don't want to tell that actually, because then they would like.
Oh, this.
So. You guys said it was written on the course doc, which like, did you check SIU classes?
No.
I can do it here. SIUC classes, I think we can do it here.
On the registering, it said it's on.
404, right?
Yeah.
Yeah, because I looked it up, but I trusted the new students' instinct because they must have just got it.
Yeah, because the police I guess in the mail and it's mentioned that it's 412.
Oh, that one, yeah, that's not reliable. That is a university classroom, yeah, that's not reliable, because I think that's why he came. There was a mistake and me and Saika talked about. I said, oh, that's a local document, we don't have to worry about it.
Okay.
So we go by this, because there should be no clashes between classrooms, yeah. So let's see. So. You guys can see this, right? Yeah.
Yeah.
Okay. Does it say anything? Boom. Oh, you have to click on it, yeah.
I think it's instructor meeting times.
Hmm?
In the left side,
On the
you
left.
see the instructor.
Where? Oh, here. This one?
No,
If
if
you
you
click,
click on the course, the same. Mathematical.
Click again?
And if you see instructor meeting times. Yeah.
Oh, here.
And that.
Oh, yeah, room 404. Okay, so we were all wrong. So, yeah, they were polite. I mean, they were standing here and right in front of me, they were chatting, and I was thinking, why are they doing this? I mean, it's disturbing my class. I was almost going to shut the door. So, but they were right. They were just passing on a message. It's our room. Okay. Okay, so surely officially we have to be there. So probably be aware between the two find out.
Okay.
So. Yeah. Yeah, most probably we will end up there. I think I would like to go by the official thing, even though Puneet is very friendly. He was already saying that, oh, we can do this. Other way, but I think we
Can you
should.
talk to them and stay here?
Hmm?
Can you talk to them so we can stay here?
Okay, here is how it's a graduate level course. Typically, these conversations are sufficient. But university administration makes it a very big deal. It is a safety issue. If, let us say, something happens to one of us and there is some emergency call that comes to the president of the university, they look for, oh, where is he? So he or she. And they expect that you're here. And if you're not here, think of real emergency, something really important. And that probably never, I mean, the chances are very low, but that's the administration side. They have a liability associated with this. So this becomes it's more challenging than what one would expect. But usually what we do, this swapping and all, and no one knows about it. It's true, and it's getting recorded, so I shouldn't be telling you these things. But yeah, it's unofficially done. Like, for example, it was Puneet, I can say, oh, okay, why don't you permanently stay there? Like he might like that room because he's more, he likes demonstrations. Maybe there are more demonstrations, or he needs more room for it, for an experimental setup to be shown. So sometimes people like that. Like many in our department like that room over this. I like this room. But many faculty in our department prefer that room over this. It's a personal choice. Okay, so. How much time gone? 35. That's not good. And only half an hour. Okay, so
Professor, we have in midterm next week.
next week again, there's a mistake. It's surely not the next week.
And
Okay,
it's not Friday, it's Saturday.
September 2nd,
October.
should be October.
Should be October?
Hold on, no.
So what's the second is Monday?
No, surely not September 2nd.
Maybe there's no midterm one.
Maybe.
Okay, we'll go through this. All these are questions I can ask you. Okay, I think it is, what I did was I took the last year's syllabus and I noticed that it's 1 day off between last dates and this date. So I just changed the date, but probably it was October and there's typo up there somehow. So I'll get back to you with it. It's surely not on September 2. I think that's not I mean, there. So since we're talking about that, let me reach that. Okay, I'll go through the syllabus. As I said, the content is going to be, we'll talk about vectors, basically vector, what if you have a 3-dimensional, or we call it third rank tensor is something that you build on vector algebra. Vector algebra you all study. What's the difference between a vector and a scalar? Just for fun.
Direction.
The direction, correct? Anything? Yeah, let's do that. Let's stick to that. And matrices, are you all familiar with matrices? For sure, right? Matrices can be thought of as a bidirectional vector in a sense. It's very loosely stated. More strictly speaking, it's the second rank tensor. So vector is a first rank tensor. Scalar is a 0th rank tensor. Matrix is a second rank tensor. Then you can go to third rank tensor, 4th rank tensor. And we will find a very convenient way to deal with such quantities. And these are very crucial in if you're doing gravity and more advanced form of gravity. That's the way it is usually done. And you will see this in special relativity a lot. So it's a very good, easy, simple tool. It's pretty much a prescription. Like first time when you study vector algebra, these are the rules, right? Or even multiplication or addition. These are rules, right? 2 + 3 is equal to 5. A vector is over 2 such numbers, and you add them. So these are rules. So you have to figure those rules out. Often it's stated, but there is a lot of rules in there, so you have to find that out. So I'll help you with that. So that's the idea. So it's mostly tensor analysis. We'll also use what is called dyadic notations for that and see how we can proceed. So that's going to be part of it. Complex analysis is another thing. Last year, I did not do complex analysis at all. So there's a give and take. So there's a lot of topics we have to cover, and it's usually a choice that comes to the classroom and probably more on me. That I like the complex analysis part, but what happens is that when I do complex analysis, I get less time on Green's function, which I feel is complex analysis is probably you have seen it somewhere, or you get chances to see it more often in other courses. The same argument I'm giving that thing. So I sometimes think that, oh, okay, choose Green's function and then sacrifice complex analysis. We'll see. We'll get a chance to interact on that. Think on that. Do you prefer complex analysis or Green's function better? And talk to me. I am ready to move this way or that way. Aryan, you usually have strong opinions on
I think
what you want.
complex is better because we
Complex.
already had that atomic answer
Green's function you had? When
did for last semester. Green's function.
Oh, you little bit because Ian. Yeah, for them it's opposite. They will see it. So so it's easier when you have already done it here. But yeah, so that's your personal choice. So yeah. Yeah, I've always done complex. I like complex analysis, especially the typically the way I do it. I feel that it is useful, but then the price we have. So we'll see. There's at least 2-3 weeks for that decision. And I was, yeah, this was what I was telling, right? I was talking about these are matrices, and at least the quantum mechanics, the way you all must have studied. Of course, when you studied quantum mechanics at an undergraduate level, there is a good bit of differential equation. That's where you see a lot of differential equations being solved. That's surely part of it, but that's nothing conceptually new in the way we see quantum mechanics. Quantum mechanics is always looked upon with almost with a glamour to the concept, in the sense that, oh, what is this? Like, why is it so different? So those differential equations have that feature, but it can be captured much more easily. The content of quantum mechanics, or the theme of quantum mechanics, the surprising part of quantum mechanics, can be captured much more easily in the two-dimensional matrices, because it's much easier to deal with. Insight is much easier there. It's almost like a vector algebra we are doing, and it is a vector space. Like you might have heard that quantum mechanics is the mathematics associated with quantum mechanics is the vector space. So I'll try to introduce that very simplistically, maybe in 1 week or 2 weeks, and it usually I won't have enough time to push quantum mechanics in there in a very deep way, but at least show some non-trivial features, and then from there you should be able to take over. Like the idea is that I give you the basic mathematical needs, and then somewhere else you will see it, and oh yeah, I know the tricks here, so you should be able to take over. So that's the sort of goal here. So index notation, dyadic, complex analysis, little bit of quantum mechanics, and Green's functions. That's broadly what we'll cover. So that's what I have written down there. What's a book that I use? That's tricky a bit. Formally, I say Erskine, the second reference that is there. That's a useful book. And again, Math Methods is pretty standard. There are lots of books in there. And the first reference that is there, it's everything that I'm talking about is in there, but it's very dense. It'll be very hard to penetrate as a beginner. But if you're going to do anything serious in physics, it's a good book to have. Okay,
Which is the main reference?
The textbook for this course officially is the second one. Okay, but that's in my opinion less useful. But again, when it comes to scoring points in the, so now there are various ways. One is that you want to have real good knowledge, you want to have a textbook or your really good handbook. That's one way of looking at it. And second is that, oh, I just want to deal with this course, forget about the subject, thing. And that's also reasonable. It doesn't mean that you're doing anything wrong in that. So if you're just wanting to survive in this course, not really survive, like do well in the course, have my lectures and I provide notes to a certain extent. They are there in the old courses. There are written notes there. You just have to go a little bit farther into the semester. There are notes and there. Click on that, and it's just that it may not be organized as lecture 1, lecture 2, and that might be useful. So, or the recordings, that helps a lot these days. At least for the last 3, 4, since COVID, we have recordings, and that also is very beneficial. At least go. Last year it was not recorded, so last to last year can be where you can begin, and so there you will see the organization that, oh, this is what was covered, and that could be a guide to begin with. And you should always go to textbook. So next is you go to the second reference if you want ERFK, and go from there. And if you need more, I'll be giving you references here and there. So textbook is, it's not one textbook, it's typically a lot of resources that I provided. Is that clear? Okay, so especially for the new students, figure that out. Going into my old course pages helps a lot. Talk to others how it goes. And all this leads to the idea that, how do I know that, for example, Green's function, you can do forever. You can spend your whole life on Green's function and still have a lot to do. So how will you ever know that, or what is expected in the course? So typically the guideline I suggest is that start with my homework. I'll be giving you a homework. If you're, see you, Abdullah. Yeah, okay. So start with my homework. If you're immediately able to do the homework after attending my lecture, then I would say you are reasonably prepared for the course. But typically that won't happen. Right? You will not be able to write down the first few lines needed for homework. So that will require also, now I'm not prepared. So go to your resources, go back to the lecture if possible, go to the textbook, go to other resources on the internet, and then figure out, and then come back to the home. As far as possible, do it on your own. If you can do it on your own, you're prepared, because that's what will be in an exam. There will be a very similar question you wouldn't have seen. At least you should be able to build the logic related necessary for that. So if you're using anything, any resource, that means you're not prepared. That doesn't mean that there's nothing wrong. Everyone is usually, just by attending a class, you cannot do the homework. That just means that you need to read more resources. You need to read more textbook, more content on the subject. Is that clear what I said? So it's kind of a loop. If you're able to do the homework, good, you can stop. If you're not able to do the homework, go to your lecture, so maybe so you can make it as a cycle, right? So there's a lecture, you begin with the lecture, then there's a homework, and there are resources. By resources, I mean textbook or anything like that. So basically, lecture and resources kind of are the same. If you're able to do the homework is usually a little hard, but then I break that into small pieces. But still, if you just blindly just look at the homework and you try to do it, just the notations might not be common. For example, if you look at the homework, the first question, what is it even asking? What does it mean, the I and the J in the subscript? So those are notations most of the time, and those are things that you get from the lecture and from the textbook. Okay, most of the rules of the game, in a sense. Okay, that's that. If there is confusion on this, talk to me again. Okay, feel free to talk to me. I think at least I believe that I'm reasonably easy to talk to, but then if not, try to anyway talk. That's the best I can say. Okay. Distribution, there will be homework for 30%. Notice it's a big percentage of the grade. It is serious. If you miss on the homework, then you lose points. So what I say is that typically what I say is it's okay to look into each other's homework. That's something that is not common in other courses. In other courses, if you look into your friend's solution, that's cheating. In most of the courses, it's cheating, especially if it's an exam, it is surely cheating. In my course, I encourage you guys to look into each other's work. So do look into each other's, do talk to each other. It's even okay to take your friend's homework and copy it down. Okay, but at least write it down. Don't take any image and send it to me. That I would, let's draw a line there. But even when you're copying, I believe that, okay, it's like copying from a textbook. You're doing something if you're spending half an hour on that. That's okay, that's unusual. Okay? So in this course alone, don't do this in other courses. In this course alone, it is not cheating. It is encouraged. Okay? So it's a collaborative work. But then you do submit your writing, you do submit it to me. And the idea is that if you're done that, you don't have to tell me. If you're done that, register that, oh, I did this, I don't understand this. It's your responsibility to go and study it before, let's say, an exam or before whenever you need it in your life. So it's okay to write it, take others and do it, but make sure you register that I did that. Okay, so that's so try to get the 30% in your hand. But statistically speaking, it doesn't happen. Many students lose it. So do collaborate. I encourage that, but at the same time, it comes out harder. Statistically speaking, people don't get 30 out of 30. Everyone doesn't get 30 out of 30. Okay, so that's nice. That means people still don't want to look into others and do it. They like it others. That's okay. Let's be aware of that. And I take all that into consideration. There is a quiz that is there for 10%. What that means is that there won't be like homework. I have printed it for you and given you. Next time onwards, it will be on the course webpage. The course webpage is. Are you aware of D2L? So are you guys aware of D2L? So there's a university course management system. You should have a login. That is, but I don't put the course materials there. So I put it on a personal webpage. It's maintained by the university. It is there on the syllabus webpage. It's it. So you can click on, if you have an electronic copy, you can reach there, otherwise type it down. There is also a mirror for this. That's what I'm going to write. There are two places it's maintained. Either one is okay. This means TC means teaching courses, and then this is 2023, that's a year, month when it begins, that's August, and then the course number, I suppose, SIU Physics 500. Okay, so everything that there's also a link for past courses there. So it's a if you reach there, you should find sufficient stuff. Okay, is that clear? Okay. Or this piece can be replaced with whatever is there in there. So it's a mirror of, so these are mirror websites, right? One is maintained under the university and the other one is a personal website that I have. So both are mirror of each other, but I just upload them both places every time. Okay. So I was saying about the quizzes. Yeah, homework usually is available on this website. You'll have to download it. Today I have given it to you in print. Next time onwards, you just go there and download it for yourself. There is also what is called quizzes. They are not structured like a homework. In a homework, I spend time, I write it down and give it to you guys. Often it's motivated from many textbooks, many resources. Quizzes are not guided at all. So usually how it happens is that I'm giving a lecture. And suddenly, like just now, I asked about a differential equation, right? Have you seen Pauli matrices? Sometimes this is something that none of us have, or none of you guys have come across. Then I say that, oh, look it up. So look up Pauli matrices and write something about it. So the goal is just to look it up, but then I need to have some proof that you have looked it up. So you just write 3 sentences on it. Okay. So whenever I give you a quiz, the idea is don't spend, or I don't want you to spend more than 5 minutes for the grade you will be earning for that. Let's say 10 minutes. But typically, hopefully, like, it is an interesting enough concept that you go and search about it and you read a little bit, 10 minutes, or maybe you get interested, or I want to read more. That's your call. I'm not asking you to do that. For the course, for the points, if you just say that, oh, this is what it is, the first 3 lines of, let's say, Wikipedia, something reasonable, you write it up, that's good enough. Okay, I just need a proof that you. Sometimes I also say that if you're usually regular, submit the question itself. Okay, I did not get time to think on it today. That's also fine. Okay, but avoid that. I mean, this is a small classroom, 5, so that's okay. If every time you have been good, I don't want you to lose a quiz point just because of that, and it plays an important role. So that's also okay. But very liberal with that, but don't misuse it. Every time, don't just say that, oh, I forgot, or I didn't have time. That's not, or that will spoil the healthy part of the course. Okay, so where does the quiz play a role? It plays more role than the 10%. You will see in this page that is 10%, and then y in equation 1. So what is y in equation 1? So let's say you notice that there is a 10% quiz plus 30% homework, right? So this is quiz, that's homework, and then there is 45% exam, right? Midterm exams, and then there is a 15% final exam.
40%.
40%. Thank you. There's an undergraduate courses, I do that. 45 and 15, so I did that for granted. Okay. So let's say, and I do this once or twice after every midterm exam. This is what I do. So let's say that you have a midterm, you don't yet have a final exam. So whatever this is, let's say you have an 80%. So you have 80 out of 100, like a typical a normal student. And it could be anywhere. Typically, this runs anywhere between 50 to 100. Okay, so usually, if you're used to a grading where 80 is B, 90 is A, here in this room, the raw score, let's call it the raw score, it can run anywhere between 50 to 100. 50 is typically low. On an average, I've noticed it runs between 65 to 100. Okay, so that's here. And notice the grades are A minus, B plus, B, and B minus. So that's the 3 C's. If in many ways a fail in this course because it's a graduate program, you get into probation, or many of you guys get into probation, get a C. Be aware of how those things. Anyway, so let's say you get an 80 here. So I take this 80 to get your total grade. You have lost 20, right? So I do 100 minus 80. So that's your total score. So that's your total. That's very good, right? So I return back everything you have lost, but then everyone gets 100. So I get a little sneaky there. So take this y, right? Y is how much ever percent you scored in your quiz. Let's say you got full 10%, then I'll give you a 1. So let's say you got an 8 out of 10. So that's 0.8. Right. So I multiply that. So that's your y. But still, if you get full percent in your quiz, you can still make it 100. Everyone will get 100. I get one more parameter in there. So this is where I decide that this is a curve parameter. So the idea is that I try to give back some points that you've lost. Typically, it's about 20 to 30%. So in 80 out of 100, I'll give you back about 4 to 6 points there. But then to get those points, you have to have your quiz good. For me, the quiz is the easiest way of judging that how much you're contributing to the course. The simplest thing you can do. If you're contributing in this, then you get everything that I return back. Otherwise, you won't get it. If you don't do anything, you don't get it. So that's a simple way for me to ask for, and it's at least in graduate courses, I notice that why is the factor there. Most of you participate well, so just do statistically speaking, it has worked out well. It has not hurt anyone back. So that's one thing. Okay, finally we come to the midterm exam. Again, how many midterm exams you want? Would you like to have more number or less number?
2 is enough.
Two is
Seems like that.
two is fine, yeah.
The reason you increase the percentage for midterm exam. Usually use 30%.
No. I don't think so. At least last couple of years, it's
To 15%, I think.
yeah, 15, yeah, it might have been 15%, that I could have changed, so 15 plus, so that's 30. Oh, so you're saying I increased it to,
Because final exam.
so maybe it was
usually
40 then, homework was 40 then. It could be, but this is from last year, so at least last year was the same. I hardly spent time on this, I just changed the date, obviously because it's September 2.
Last semester we had piano with you, it was final exam was 30%.
Okay. Let's stick with it. Like, as I said, I didn't think about it at all yesterday. I just took the last year seemed successful, so I didn't have any issues, so I just except the content I might move. Last year I didn't do complex analysis, so that might be the only big change. I might do. Okay, midterm exams. So you all agree 2 is good enough, right? 2 exams. So I distributed equally about so there are 16 weeks usually in a semester. So the 6th week is a good place for a midterm, 1/5 or 6th week. I think probably September 2. Sorry, October 2 probably is a Friday, probably. But I will check and correct that and we'll make the correction. Surely not on the 3rd week, like September 2 is not even, yeah, September 2 is a Friday, right?
It's
No,
no
it's
Saturday.
So it's not even a working day, so there's no way we can have it. Yes,
Second was Friday, September.
October 2nd, what is it?
It's Monday.
It's Monday, so even that doesn't work, okay, so at least it can work, but it is not what I've written.
You might have meant the 22nd.
Second is Friday.
Oh, that's awesome, okay, so it might be September 22nd, yeah, okay. But let me decide, like on Friday, I will give you the correct updates. Yeah, that's what it is, you see a rough idea of what it is, and it's 4 minutes remaining, but let's do something. Okay, 5 minutes learning, okay. At least you should know what the notation in the homework is. Niranjan, is it all going good until now? Probably that was not necessary for you.
Yes, yes. Yeah, everything is good.
Okay. So let's talk about vectors. And oh, we need a quiz, right? What's the difference between, so there's a quiz. What's the difference between vector versus vector field? Give an example of a vector field. Give an example of a vector field you have come across. All of you have come across it in your undergraduate right now. Yeah. Oh, I was just yeah, that's a quiz, but we can discuss it here also.
Like magnetic.
Yeah, magnetic field is a vector field, electric field is a vector field, gravitational field, G that we say it's 9.8 meters per second square, it's just constant everywhere. But if you go a little farther, it's not constant, so that's a vector field, but even if it's a constant, it could be a vector field. So those are examples of vector fields. How is it different from a vector? It's at every point. At every point, you have an information about a vector, so it's a field in a sense. I don't think that field really means it. I think you really think of it as a field of grass, right? That's a direction at every point. But that field really has a technical meaning in mathematics. So that's also should be aware of. Okay, so that's your quiz. So let's talk about vectors for a moment. Typically, we say vector A, not a vector field at this point, a vector A. The way we visualize the vector very simplistically, that's sufficient here. We seem to always have an axis. Right? Is that necessary for a vector? In principle, right? Someone, I mean, when I ask you what a vector is, the direction, right? So I don't need this, right? That's not needed, right? So what is a vector? This is a vector. That's it, right? It has a length and it has a direction, right? If you have that visual capacity, if I point it in that direction, what direction should you walk? I'll give it to you. If you're talking on phone or social media, it might be harder because then you have to describe or north direction with a landmark. So it gets harder when you're really writing it down. So that's a vector A. It doesn't read an axis at all. But we always study, when we are studying a vector, we say there's an X component, there is a Y component. So we pick two axes. It's convenient to write a vector or do the algebra of a vector because we want to add and subtract. And we know addition of 2 plus 3 is equal to 5. We want to use those resources. We don't want to build new things, right? It can be done geometrically also, but it's easier to work with existing ideas. So you take any two directions. Typically it's X and Y, but let's have more. This is E1, this could be more general. Any two direction, doesn't have to be X, Y. It could have been in this direction. Pick any direction you want, north and south. Oh, sorry, north and south are the same direction, right? It's plus and minus. It's north and east, or I'd say, right? North and east, you can say. So and let's stick for a moment in 2 dimensions. Okay, so I'm almost done with this. So then you say this is a component E1 plus A2, E2. So you would say draw a perpendicular line. Perpendicular has to have a meaning. It's called orthogonality. We'll talk about that. Right. So that's A1. That's A2. So you often say it's a projection. The component is a projection of the vector along that direction. So that's your A1 and A2 are projections and that. But let us say we are all like, for example, X and Y direction has become so standard that most of, like, especially when you're doing an undergraduate course, you never write IJ, right? Often everyone understands that we are working in rectangular coordinate. It's very less often that you would do spherical coordinates or cylindrical coordinates, but you can change coordinate. But if you are mostly sticking to your coordinate system, this becomes not necessary, but you lose a lot of information. Remember, it's a notation now. You can say that, oh, A1 and A2 is sufficient. Okay. But this is simplification, like this is not really equal, right? I'm really getting rid of information there. Without E1 and E2, it's not complete information, but often it is okay to work with A1, A2. Right? You get lazier because you want to build bigger things, right? Tensor and so on. You get lazy. You want to make this compact. The idea is to make this compact so that we can do bigger ideas. And this is A1 and A2. You start writing this as AI, where I is understood to be 1, 2. In fact, if it is 3 dimensional, it's 1, 2, 3. If it is 4 dimensional, it's 1, 2, 3, 4, and so on. That's an index. So a vector suddenly is So a vector A is equal to AI, not equal again, as I said. Or say, that there is information, if there's a lot with a lot of implicit assumptions, that's your vector. And a tensor will be, so let's say there's another. A matrix will represent it by two vectors kind of thing. This will be Mij. Two index. What that means is now there are two directions it can go, and that's what we'll talk about. So at least you will see the notations in the homework. So I did a little bit today rather than just. But we should stop. It's 3 minutes off the time. Thank you, and we meet on Monday and Friday.
Yes.
Right, and
Here.
between 4:04 and here, I don't know. I'll try to be here, but I have to be polite to them also. So I don't want to snatch the. That's what we got. So I would like to be here, how about that? But we'll see. Yeah.
Alright.
Okay, thank you. Have a good semester.
No, my next class is in here.
Yeah,
Yeah.
oh, okay, that's convenient.
Do you want to help me with this?
See you, Niranjan.
See you, Dr. Sajis. Thank you then.
Okay, yeah, thank you, yeah. I think,